Assalamu alaikum. Today we will discuss the Dalton law of partial pressures and the mean-free path. This is both depends on kinetic theory. So, gas mixture or partial pressures. In a gas mixture, gas A and gas B and so on, the partial pressure of gas A equal the pressure the gas would exert if it was in the container by itself. Okay, so Dalton, he put the law for these partial pressures and state that the total pressure of mixture of gases is the sum of the partial pressure of the individual gases in the mixture. So B total تساوي pressure A زائد pressure B زائد pressure C and so on. And BA is the partial pressure of gas A. Okay. In this one, or the pressure A or the gas A is N2, and we have 0.01 mole من N2 in 1 liter flask at 25 Celsius exert a pressure of 186 millimeter Hg. Okay, then the pressure equal 186 millimeter Hg. The oxygen or gas B equal 0.005 mole O2 at 25 Celsius. In a flask, 1 liter, and the pressure is 93 millimeter Hg. So gas A, N2 and O2 are mixed in the same 1 liter flask at 25 Celsius. So the total pressure is 279 مليمتر Hg. أنا عندي 93 مليمتر Hg and 293 مليمتر Hg. So is the sum of the pressure of the individual gas. Okay, so B total equal pressure A زائد pressure B and so on. And for the ideal gas, the law of the ideal gas which equal NA في RT over volume زائد NB في RT over volume. Look, NA and NB is different, the number of moles, but R and T and V, it's the same. Okay, so P total equal NART over V زائد NBRT over V and so on. So NA زائد NB and so on. ناخد هنا عامل مشترك مضروبة في RT على V وتساوي N total في RT على V. So BA على B total تساوي NA على N total وتساوي XA, and this XA is the mole fraction of gas A. Note that all fraction XA زائد XB زائد XC لازم يساوي 1. إذا بدنا pressure A راح تساوي the mole fraction of gas A مضروبة في B total. Even example, 1 liter sample of dry air at 25 Celsius and 786 millimeter Hg contains 0.925 gram N2 plus other gases including oxygen, argon, and carbon dioxide. Determine the partial pressure in millimeter Hg of N2 in the air sample. Determine the mole fraction and mole percent of N2 in the mixture. Okay, first of all, we have to convert 0.925 gram in N2 to moles on 2. Then, how to convert 0.925 gram into ضرب 1 مول into على 28 جرام into وتساوي 0.0330 y 28 جرام into. Okay. Substitute into the ideal gas law, 25 Celsius equal to 298 Kelvin. So the pressure of N2 equal N ل N2 في RT على V وتساوي 0.80780 أم وتساوي 613 مليمتر Hg. Okay. Determine the mole fraction of N2 in the air. Mole fraction of N2, the pressure of N2 over P وتساوي 613 ملم Hg على P تساوي 786 ملم Hg وتساوي 78%. Okay, another topics related to the kinetic theory is the mean free path. Mean free path is the average distance that a particle travels between collisions is called mean free path. إذن هي عبارة عن ال average distance between two collision molecules. Okay. إذن in order to have a collision, the centers of two particles of radius r, this is two particles, this is particle 1 and particle 2 or molecule A, molecule B. So the two particles of radius r must approach to within a distance of 2r. Then the distance from the center is d. The picture in the illustrates this point. Okay, this is two molecule and between two center is the d. And the collision cross section sigma equal by d square. This is the collision cross section. Sigma by d square or area equal by d square. Okay. Then mean free path is the average distance molecule travel in between collisions and gives by this relation equal lambda or Lm or whatever, lambda equal 1 over the square root 2 by d square n over volume, and d is the diameter of the molecule. Okay, and n over v is the density of molecules. Okay, how the derivation of this relation or derivation of mean free path? We will derive this equation using the following assumption. Molecular N left moves to right with average speed v, while other molecules are at rest. So it collides with molecule within cylinder. If n number of molecules and v volume of the container concentration of molecule is equal N over V. إذا ال concentration of molecule تساوي N over V. Number of collagen with cylinder it's given by N اللي concentration of molecule N over V مضروبة في الفوليوم of cylinder. والفوليوم للسلندر هي عبارة عن ايش؟ الباي دي سكوير. اوكي، الفوليوم باي دي سكوير مضروبة في في تي and VT is the distance. اوكي، is V average مضروبة في التايم is the distance. During the collision of these molecules. Okay, so it's by d square. إذن lambda هي عبارة عن length of path during time. Length of path during the time is equal VT, V average VT. Okay, this is the length. And مقسومة على number of collision within cylinder. Number of collision within cylinder اللي هي باي دي سكوير في تي في n over v وتساوي 1 over باي دي سكوير n over v. Okay. إذن this is the area or the cross section of the cylinder. Okay. And this is the molecular size. إذن لامدا تساوي 1 over the square root ل2 لباي دي square n over v. This, the square root over 2, we have cancelled two velocities in above equation, but actually the v is the numerator is the average velocity, and v is the denominator is relative velocity. Then we have the average velocity and these relative velocity. So it will have corrected by the square root 2 by this factor. Okay, how? This v relative تقريبا بتساوي the square root ل VR square وتساوي هاي جذر 2 في v. إذن, and hence we obtain an expression for lambda as follows اللي هي lambda بتساوي تقريبا 1 over the square root ل2 في n sigma, where sigma is the cross section of cylinder وتساوي by d square. طيب, substituting the pressure nkbt إذا بدل n بدنا نعوض B over KBT. إذا lambda equal KBT over the square root ل2 في B في sigma. So to increase the main free path by a certain factor, so the pressure needs to be decreased by the same factor. إذا تتناسب تناسب عكسي مع مع البريشر. اوكي. إذن كل ما قللنا البريشر كل ما زدنا المين فري باث. In summary, the main scattering time is given by time scattering tau بتساوي 1 over n sigma في v relative, where the collision cross section sigma is pi d square. D is the molecular diameter and VR equal square root la V. So the mean free path is lambda equal تقريبا بتساوي 1 over the square root 2n sigma. We have example from the book. Calculate the mean free path for gas of N2 at room temperature and pressure. For N2, take the diameter equal 0.37 nanometer. So the solution The cross section is pi d square, and we have the pressure 10 القوة 5 باسكال, and at room temperature or T equal 300 Kelvin. So the number density is N, the pressure over KBT وتساوي 10 القوة 5 مقسومة على 1.38 في 10 القوة ناقص 23 في 300 تقريبا تساوي 2 في 10 القوة 25 متر قوة ناقص 3. This yield to lambda equal 1 over the square root of n sigma, and which equals 6.8 في 10 القوة ناقص 8 متر. Another example, suppose we have oxygen molecule at 300 Kelvin at pressure 180 m with a molecule diameter 290 picometer. What is lambda, what is V, and frequency, where frequency is defined as the frequency of collision in an ideal gas. إذا lambda equal 1 over square root 2 by d square and v. So find lambda هو تساوي, we know bv تساوي n kt, and lambda substitute these instead of n over v gives this relation, and put the numbers. So lambda equal in this case 1.1 في 10 القوة ناقص 7 متر, وهي تقريبا بتساوي 380 من الديامتر. Okay, what is V? The velocity. The speed of molecule in an ideal gas use the RMS speed. So VRMS تساوي the square root of 3RT over M, and which equal 483 متر لكل second. What is the frequency of collision? The frequency equal VRMS over L. So the frequency 483 على L 1.1 في 10 القوة ناقص 7 تساوي 4.38 في 10 القوة 9 كل سكند. What is the time between the collision? Time بالتعريفه بيساوي 1 over the frequency, and V gives about 2.2 nanosecond. So this is the end of this lecture, and thank you for your attention.